Okay, guys, so I'm going to explain to you real quick how to do 10, exercise 1. And we're going to be focusing only on the HFF value for the initial state and write the action and the fact set or whatever for RPG algorithm, whatever. The RPG algorithm basically states that it's like you apply actions. And as you can see, we have, let's say, propositions, which are just facts. Like, oh, the car is at A or car is at B, for example, car is A, B, C, D, or E. And the friend or pizza is either at A, B, C, D, or E, or in the car. The I is just initial state we're in. G is the goal state we want to have. So yeah. And A is just action, so we can drive to X to Y, or drop the friend at a certain point, pick up the friend at a certain point, drop the pizza at a certain point, or pick up the pizza at a certain point. So in this case, the RPG algorithm, what it does is basically, if you see this, it has preconditions. Like the precondition for this action to run is that the car has to be at X, and we add a new fact that is car is at Y because we move from X to Y, which makes sense, and we delete the fact that the car is at X. The RPG algorithm basically removes the deletion. Like there's no deletion. So everything stays in a single thing. So the car is simultaneously at X and Y after the action. It's kind of stupid, but that's how it works. Another thing is that in this case, the peak of the pizza infers that the precondition infers that the pizza has to be at the same point as the car, and the friend has to be in the car. So we cannot pick up the pizza first. We have to pick up the friend first. So what do? This is initial state, right? We're at A, the friend is at B, the pizza's at C, and we want to pick up the pizza and have the friend all at E. And we are everything at E. We draw the pizza, we drop the friend, and the car is at E. That's basically what we want to do. And so how do we do this? So basically, we have our propositions that are possible as the car is at X, or that the friend or pizza at some point. The initial state is that we have car at A, the friend is at B, and the pizza is at C. And the goal is for everyone to be at E, basically. The actions are drive to X. We can drop the friend, pick up the friend, drop the pizza, or pick up the pizza. Pick up pizza has a precondition that we need to have the friend inside first. So the first thing we do is create something called F0, which is going to be basically the initial state. So this thing is the same as here. So we copy paste it. And then we apply the rules that are possible to be done at that scenario. So if car is at A, we can drive obviously to B. We can drive to C. So A to B, A to C, and A to D. So A to D. Then we have F1, which is simply another propositional thing. So what happens after we apply each of these rules? So if we drive from A to B, now the car is at B. If we drive from A to C, the car is at C. If we drive from A to D, the car is at D. Same thing. And then the action says, okay, given that we're at B, what can we do? Okay, we can go back to A. Or if we're at C, we can back to A. If we're at D, we can go back to A. Or we can go to E as well, as you can see. Or we can pick up the friend at B. Then is the same thing. Okay, F2, F2 propositions. What is true in this case? If we go to E, the car is at E now. And if we pick up the friend at B, then the friend is in the freaking car. And now what can we do? Well, because we have said that we do not delete any of the conditions that we had, the car is still at A, right? And C. So we can drop the friend at A, B, C, D, E. And we can also pick up the pizza because the car is also at C. And now we have the friend inside the car, so we can pick it up. We can also drive from E to D, right? So again, propositions, what happens if we pick up the pizza or drop friend or whatever? So if we pick up the pizza's in the car. If we drop the friend at any other point, well, the friend is in A, B, C, D, and E. And now we apply the rules, the actions possible in this case. So if the friend is, well, it doesn't matter if the friend is at E, whatever. Now we can drop the pizza as well, anywhere in A, B, C, D, or E. Pretty easy. And now if we apply our action, what happens? Well, the pizza is going to be in A, B, C, D, or E. And that's pretty much it. That's everything we have to do. That is how we expanded our forward thinking RPG algorithm. But now we want to backtrack and compute HFF. HFF is basically given the goals that we have, what are the actions that we had to take in each level for us to reach our goal. So to work this, we have to work this in the inverse way. So what we do is we take this whole thing, right? And we go from the top to bottom. So we start with G. G4 is simply going to take propositions in this case that we want to be in. We know for a fact that the first goal, one of the goals, is to be at E. The pizza has to be at E, right? The friend has to be at E, and the car has to be at E. So let's mark those really quickly. So the pizza has to be at E. The friend has to be at E. And the car has to be at E. Let me find it here. Okay, so G4, what do we do in G4? G4 is simply going to search for all the possible actions that we want. So in this case, we want the pizza, right, to be at E. That's it. That's it. Pretty simple, right? However, the next step is seeing what gives us, like this is a block. Basically, you can think of it as a block. Actually, let me just make another color maybe. Maybe had it like, oh gosh, like so. So think of this as a block, right? And this is another block. So whatever we have a new number, a new sub-index is a new block. So this is a new block here. And so on and so forth. And then this one is another block as well. So what do we do? Okay. At this point, it's pretty simple. We've understood what we have. Oops, hold on. I have to change this guy. Okay, perfect. Whew, okay, so basically we're at pizza E, and we want to see, okay, what kind of actions did we take from A3, to be at pizza E? Well, we have to drop the pizza, right? So we just mark this as blue. That's it. Okay, cool. So for this action to be true, what did we do in our propositions? What proposition had to be true for us to apply this rule? Well, the pizza has to be in the car, right? We cannot drop the pizza. We don't have the pizza in the car. So this one has to be added. So G3 is going to be the goal, whatever goal we have. So add friend, yeah. And the thing that we found out. Oh, because of drop pizza E, we have to have this inside. And that's it. That's pretty much it. Now, we enter G2. Yes? So let's just mark. Oh, no, that's it. So now that we have that, we want to know, okay, for at friend E and at pizza car to be true, what actions do we take in G2? Just G2 here. What actions do we have to do in G2? For the pizza to be in the car, well, we have to pick up the pizza, right? So let's mark this. And what do we have to do? Well, we have to drop the friend at E, obviously. Okay. Okay, great. Now, from G2, what do we need for drop friend E to be true? Well, the car has to be at E, evidently. So you cannot drop the friend if we're not there. Pick up the pizza. What does that imply, right? For us to pick up the pizza, we know the precondition is that the friend has to be in the car. Thus, we add this as well. Great. Now let's go to G1. Whew. Oh, gosh. Up until now, we have dropped the pizza at pizza car. No, that makes no sense, man. Hold on. Yeah, drop pizza. Pick up pizza. Drop friend. Yeah, perfect. So now that we have this and we have all of these cases, what actions do we need for the car to be at E? Well, we have to drive from D to E, right? And what conditions do we need for the friend to be in the car? Well, simply, we first have to drive. No, actually, we don't have to drive from B to A. You just have to pick up friend from B, don't we? So we'll just do this blue. Okay, great. So what things from G1 do we need to have for this to be true? God damn. So for example, if we want to drive from D to E, then car has to be a D, right? So we add this. If we want drive to D to E, what else do we need? Let's look at this. Drive D to E. Car has to be a D, obviously. If we want to pick up the friend, well, the car has to be at B, evidently. But what about car at C? Well, the car has to also be at C because it has to pass from C to D, right? Or so I think. Let me think. Yeah. So we have to add this as well. Boom, boom. And for car at B to be true, what do we have to do? Well, we have to drive there, A to D to B. So mark this. If we want to be at car at C, we have to drive from A to C, evidently. And we want from the car to be at D, we have to car from A to D, evidently. So ultimately, what's HFF? Well, simply put, HFF is the sum of all the actions we took to get to the end. So in this case, HFF is going to be, let's count up, okay? Let's count the blue one. So 1, 2, 3, 4, 5, 6, 7, 8. And that's HFF, 8. And that's it. That's pretty much it for this exercise. Then they tell us that we have to do heuristic and stuff. It's a stupid exercise. To be fair, run the A star search problem as and use as H plus the heuristic. If several nodes have the same GH plus H value, spend the value of the largest value in the assertional dimension that legible or true. Okay, so if we want to actually understand this one, yeah, it's kind of awful because there is a solution involved, but it's really, really big. So what we're gonna do is we're just gonna study it. Exercise 10. Let's do airdrop here. So we can look at it together because it's too long. Like it's too long to write down. And just open it in Notability. So as you can see, we have this. They did the same thing, right? And that's about it. Whatever. And yeah. So as you can see, what they do is they take every single possible case and it's god awful. Now you can go off with it and it can take ages, right? In this case, I'm not sure what G means nor H. G, they're telling us it's the cost that we do, but I'm not sure. Oh yeah, G is how many like arrows we've done, like 1, 2, 3, right? And then if we do these 4, this is gonna be 4. This is gonna be 4. It's like how many units, like each action costs 1 unit. But H, I'm not sure what H plus means. Let me just check real quick with ChatGPT. What do they mean with H plus? What is that heuristic? Oh, okay. H plus is the minimum number of actions needed to reach a goal if we delete all delete effects of actions. So in this case, if we are over here, what do we have to do, for example, for us to get to, holy smokes, let me think. That's an interesting one, man. As you can see, it just basically just all the possible cases. It's horrible. But basically, it's asking us, given that we are here, right? How many actions do we have to take for us to be in our goal with by not deleting anything? So we have to go to B, so that's 1, and then pick up the friend, which is 2, right? Then we have to go back to we don't have to go back to A because we're already at A, so to speak. But we gotta go to C, so that's another one. And then from C we have to pick up the pizza. That's another one. And then from C we gotta drive to D, so that's another one. Drive to E, that's another one. 1, 2, 3, 4, 5, 6. Drop friend and drop pizza. And that's it. That's 8. In this case, we can see another one. Let's check this out. So in this case, oopsie daisy. Let's see where we can see one where I have an interesting that it's not h equals to 8. Let's see this one, for example. we've driven from A to B. Let's check. We're focusing on this one basically. And let's say we drive from A to B, so that's +1. But A to B is already like drive AB. So car is at A. Friend is at B still. At B. Or well, at B, whatever. Oh no. At friend car. But it's also in freaking B. Because we don't delete any of the stuff in this case with the H plus heuristic. And we already are in cars also at B. Gosh, I wrote that horribly. Car at B. So now let's just check it out. What do we have to do for us to get the pizza? So we have to drive still. Let's drive first to C. So that's +1. Pick up the pizza +1, right? Then drive to D +1. Drive to E +1. Drop the pizza, drop the friend, +1. So that's 6. So that's what the H plus heuristic means. We're not going to do this because I don't think they're going to ask this in the class. So this is ridiculous. But you get the idea. This is pretty much exercise 1. So yeah,